Number one, first thing is to identify the conclusion and the premise statements. We've got this nice conclusion indicator, therefore, indicating that the statement that follows is our conclusion. And we've got the word and here connecting two statements that could stand on their own as complete sentences. And that's a good indication that both of those statements are premise statements. Okay, I've chosen as the terms for this argument, physicists, represented by P, scientists who theorize about the nature of time, represented by S, and people identical to Stephen Hawking, represented by H. Now, if you have different letters representing your terms than what I have, you want to create a little cross-reference for yourself so that you can compare your version of the argument with mine. Okay, so now we're ready to translate all of these statements into categorical, standard form categorical statements. We could do that by jumping right into representing statements symbolically using our letters P, S, and H. I chose to write them out as standard, ordinary language, standard form categorical statements. So the conclusion is expressed as all people identical to Stephen Hawking are physicists. And the first premise has a little important clue in it here. The phrase the only. That tells me that whatever follows the phrase the only is going to be the subject term of my statement. So my first premise is all scientists who theorize about the nature of time are physicists. And then my second premise is going to be all people identical to Stephen Hawking are scientists who theorize about the nature of time. So when I represent this argument symbolically using these as my terms, I have all S or P, all H or S, therefore all H or P. So as long as you identified the conclusion correctly, you now want to make sure that whatever your argument yours looks like, or whatever your argument looks like, whatever terms you chose, that you have an argument that's in the form AAA figure 1, with your middle terms being connected by a line sloping downward from left to right. When we create a Venn diagram for this argument, it looks like this. All the S's are P's, so all of the S's in areas 1 and 2 have been eliminated, so that all the S's that exist are here in areas 3 and 4. All H's are S. Therefore, we shade out areas 5 and 6, and that leaves only area 3 where any H's can be. Therefore, all the H or P follows as the conclusion to these premises. When we check this argument using the 5 rules for categorical syllogisms, we determine which of our terms are distributed. All of our subject terms are distributed. First rule says the middle term S has to be distributed at least once, and it is. The second rule says if there's anything distributed in the conclusion, it has to also be distributed in the premise. H is distributed in the conclusion. It's also distributed in the second premise, and none of the other rules apply because there's no features of this argument that are relevant to those rules. And that proves that this argument, which is in the figure of AAA1, is unconditionally valid.